This video is about the quantities of circular motion: time period, frequency, angular displacement, and angular velocity. So first let's talk about time period. Remember that we're talking about a circle, so I'll draw a circle here. Not a very good circle, but that's what we're going to work with. Alright, so time period is the first quantity that you need to know. Okay, time period is the time taken to complete one rotation of the circle. Okay, so if I have an object here, and the amount of time that it takes, and say it goes around the circle, and it took 5 seconds, that means my time period is 5 seconds. We represent time period with a capital letter T. It's usually measured in seconds. However, it can be measured in any unit of time. For example, the Earth goes around the Sun in a time period of 1 year, and the Moon goes around the Earth in approximately 1 month. The second quantity that you need to know is frequency. So if time period's how long it takes to complete one rotation, frequency is kind of the flip of that. It's the number of rotations or revolutions per time period. Okay, and so if I were to, maybe let's draw another different circle. So if I were to take a different circle, and I were to go from this point back all the way around and complete one revolution, and that took me, say, half a second, that means that I could have 2 rotations per second, so my frequency would be 2. Frequency is the flip, or the inverse, of period. So frequency is equal to 1 over the time period. And because it's equal to 1 over the time period, its units are 1 over, for example, seconds. Seconds to the -1. And we have a special unit for frequency called per second, which is the hertz, which we abbreviate Hz. In equations, frequency will be a lowercase letter f. Okay. What other things do you need to know? You need to know something called angular displacement. Okay. So angular displacement is the angle swept out by a line joining the body to the center. So if I were to picture this, I have my circle. Okay, I have my object. Let's put it over here. If I were to draw an imaginary line from the center of the circle to my object, and as my object were to travel along this arc up to here, this line will have swept across this angle theta. And this angle theta will be my angular displacement. We measure the angle that we're displacing the object in radians. Okay. And the last quantity you need to know is something called angular speed, which we represent with a Greek letter omega. It looks kind of like a W. Okay, and so if angular displacement is the angle swept out by a line joining the body to the center, angular speed is how quickly this angle is swept out per time. So this is normally measured in radians per second. And sometimes you'll see it represented as something called angular frequency. This is the exact same thing as angular speed. And they're both represented with the Greek letter omega. When if we were to write this in terms of an equation, we would say that, so let's draw another circle here. Okay, so if I were to take my object, it has a line joining it to the center, it goes around my circle in some amount of time, we would say that our angular speed, omega, is equal to how quickly this angle is swept out as it goes around the circle per the amount of time that takes. Okay, and then I know that this is a circle, and I know that a circle is 2 pi radians around. So if I go half a circle, I've gone pi radians. If I go all the way around a circle, I've gone 2 pi radians. So if I were to say that I went all the way around this circle, I've gone 2 pi. And if it took some amount of time period, we represent time period with a capital T. So 2 pi over the time period is also equal to omega. And remember that frequency is equal to 1 over time period. So you could also express angular speed as 2 pi frequency. Okay, that's it for now.